Okay students, so in this part we are going to solve some previous year IIT-JEE questions. I have collected few important questions from the previous year IIT-JEE examination. This question will help us in understanding this chapter more clearly and conceptually. So let us start. Okay students, so now let us solve some previous year IIT-JEE questions. Let us start with question number 1. Two identical PN junction may be connected in series with a battery in three ways as shown in the adjoining figure. So in the figure we are given three circuits, circuit 1, circuit 2 and circuit 3. Okay, and two PN junctions are connected in series in each of the circuits. Okay, so we have to find the potential drop across the PN junction are equal in. So we have to see that in which of the given circuit the potential drop across both the PN junction will be equal. So first of all, let us analyze each of the circuit. Before this, let me tell you that if a PN junction is in the forward bias case, okay, forward bias case, so that means a positive voltage, more P side is more positive as compared to the N side. Okay, so for this case we can assume or we can replace them by a we can replace PN junction by a short circuit, because we know that in case of forward bias PN junction diode offers a very low resistance. So ideally we can say it will offers a zero resistance. So we can replace it by a short circuit case. While if a PN junction is a reverse bias, okay, so in that case we can replace it by a open circuit, because it will offer a maximum resistance or very infinite resistance, we can say. So it will act as an open circuit case. Okay, so now if we observe the circuit number 1, so in circuit number 1 this first PN junction is connected in a forward bias, because P is connected to positive and N is connected to negative. While if we see the second PN junction diode, here N is connected to positive and P is connected to negative. That means this is a reverse bias case and this is a forward bias case, right? So we can draw an equivalent circuit for this, and this will be first is a forward bias, so short circuit, and second is an open circuit because of a reverse bias. So from here we can see that the potential drop across both will not be equal. Okay, because potential drop across first is 0 and potential drop across the second is equals to the voltage applied from our external battery source. Okay, therefore circuit 1 will not be our answer, right? So now let us see circuit number 2. Okay, in circuit number 2, if we see first PN junction is connected in a forward bias, because positive is connected to P and negative is connected to N. Okay, and if we see the second PN junction, this is also connected in a forward bias, because positive is connected to P and negative is connected to N. So both are forward bias. So we can draw its equivalent diagram or equivalent circuit in which we can replace both the PN junction by a short circuit. So we can see that the potential drop across this PN junctions in both the case is equals to 0, right? And both are equal. Therefore, the circuit 2 will be our answer. Okay. Now let us see circuit number 3. So if we see in circuit 3, so if we observe each of the PN junction diodes, so if we see first PN junction, in this case N is connected to positive and P is connected to negative, while in case of second N is connected to positive and P is connected to negative. That means in both the cases the N type is connected to positive and P type is connected to negative. That means in the reverse bias, both the diodes are in the reverse bias case. So we can replace them by an open circuit case, right? So we can replace them by open circuit, and therefore the potential drop across both, we can say that they will be equal and will be equal to the voltage applied from the external source. Okay, therefore circuit 3 will be also an correct option. Therefore if we see the circuit 2 and 3, so option B says that circuit 2 and 3 will be have the same potential drop across the PN junction. Therefore B is the correct answer for this question. Now let us move on to the question number 2. Question number 2 says that in a semiconductor diode, P side is earthed and N side is applied a potential of minus 2 volt. Then the diode shall conduct, not conduct, conduct partially or break down. So first of all, to see whether the diode is conducting or not, we have to see that whether it is biased in a forward bias or in the reverse bias case, right? So first of all, let us see. In the given scenario, we are having a PN junction diode and we are told that P side is connected to earth and that is grounded, a 0 volt, okay? While the N side is connected to a potential of minus 2 volt, okay? So N side is connected to a potential of minus 2 volt, and if we see from here, the P side has having a more potential as compared to N, because this is a 0 volt and this is a minus 2. That means a P side is having a more potential as compared to N side. That means it is biased in a forward bias case. And we know that whenever the diode is in the forward bias, it will offer some very low resistance and hence a conduction of current or the movement or the flow of the electrons will takes up, and this will build up a current in the circuit, and hence this semiconductor diode will conduct, right? Therefore option A will be the correct answer. Okay, we cannot say option C because we cannot say partially conduct. Whether if it is in a forward bias case, it will conduct, right? Therefore option A will be the only correct answer. Now if we see question number 3, the impurity atoms with which a pure silicon should be doped to make a p-type semiconductor are. We have to see from the options that which of the impurity atoms, okay, which if we will add them or dope them in a pure silicon semiconductor, then that intrinsic will becomes a p-type semiconductor, right? So we have learned that to make a p-type semiconductor, the impurity should be trivalent, okay, or acceptor impurity. That means trivalent means it should have a 3 valence electrons in its outermost shell. Okay. So if we see from the options, so option A, phosphorus. Phosphorus is a pentavalent type of impurity. That means it will not be useful for making N type, but it will be useful for making P type. Sorry, it will not be useful for making P type, but it will be useful for making N type. Okay. Therefore, we want a impurity should be such that it should make a p-type semiconductor, right? Therefore option A will not be the correct answer. Again, if we see option B, antimony. Again, antimony is a pentavalent type of impurity, okay? Therefore this will not be the correct impurity to make a pure silicon as a p-type semiconductor, okay? Now if we see boron, yeah, boron is a trivalent impurity, and therefore if we will dope this boron in the silicon semiconductor, therefore then it will make that intrinsic semiconductor as a p-type semiconductor. Therefore C is the correct answer. Let us also see option number D, bismuth. Bismuth is again a pentavalent type of impurity. Therefore this will also be not useful in making the p-type semiconductor. Therefore only correct answer is option number C. Now let's see question number 4. Assuming that the junction diode is ideal, so we have to assume that the diode given to us is ideal. Okay, ideal means if the diode is in the forward bias, it will be replaced with a short circuit. Okay, so ideal means forward bias, so short circuit, and if it is in the reverse bias, so it will be the open circuit case. Okay, so we can replace them by short circuit or open circuit depending upon the type of biasing. The question asked is the current in the arrangement shown in the figure is. So you have to find the current in this circuit. Okay, so if you see in the circuit, this is a diode, this is a P side and this is a N side. Okay, and if you see in the circuit, P is connected to 1 volt and N is connected approximately equal to 2 volt. There will be some drop across this resistance, even though the voltage at this point will be greater than 1 volt. Okay, therefore we can see that the potential drop across or the potential across the n type is more as compared to p side. That means this is a case of reverse bias, and we know that whenever the diode is biased in the reverse bias case, we can assume it as a open circuit case. So if we assume this as an open circuit, so then we can see that there will not be any path for a current to be flow, right? Therefore there will not be any current flowing through this circuit, therefore the current will be zero, and therefore the answer is B. Now let us solve question number 5. The energy gap separating valence band from a conduction band is 0.7 electron volt for a material, hence it is a metal, germanium, silicon or non-metal. First of all, if we see, we are given that the energy gap basically is the difference in energy between the lowest energy in the conduction band and the highest energy in the valence band, and conduction band is on the top and the valence band is on the bottom. So this is the basically energy gap Eg, and given to us is equals to 0.7 electron volt. In our chapter we have seen that the silicon has the energy gap of 1.1 electron volt, while this germanium has the energy gap of 0.7 electron volt. Also we should know that the metals, in case of metal, the conduction band as well as the valence band overlaps, so therefore there will not be any energy gap in between them. Okay, so therefore we can see that the 0.7 electron volt is for the germanium, and therefore the material will be a germanium semiconductor. Therefore the correct answer for this question is option number B. If you still have any doubt, you can post them for free on our website askIITians.com. Click on an option ask a question. After clicking over here, you can select the category of your doubt. After selecting your category, type your doubt over this box, and if you want to attach an image of your question, you can also do that by clicking over here. After this, please click on a button ask a question. The expert at askIITians will answer your doubt within 24 to 48 hours. Okay students, so we have studied semiconductor devices. In this chapter, we have started with the introduction of the semiconductor. We have seen what are semiconductors and how they differ from the metal and the insulators. We have also seen the energy band diagram of semiconductor as well as metals and insulator. We also started with the types of semiconductor. We have seen the two types of semiconductor, intrinsic and extrinsic. In extrinsics, we have also seen N-type and P-type. After all this, we also seen the Fermi energy level and the mass action law. Then we started with the PN junction diode. This is basically a semiconductor devices fabricated by N-type and P-type semiconductor. We also seen how it works. After these, we have seen how the conduction in metal as well as the semiconductor takes place. The very important topic called breakdown in PN junction diode was also discussed in this chapter. We also seen what is breakdown and what is the cause of breakdown. We have also seen the very important concept called Hall effect. We have also seen what are the applications of the Hall effect. At last, we also discussed some previous year IIT-JEE questions, and I think you all have understood them very well. So this was all about this lecture. For more like videos, stay tuned with askIITians.com.